Hello and welcome all. Today I'm tackling something called beautiful triplets on HackerRank. Let's check this one out. Given a sequence of integers a, so a is a list, a triplet is beautiful if the index, so the values are indexed by I, J, and K. Okay, so the first value is position in front of so it's basically sorted is what it's saying. Like I is less than J, which is less than K. So the values are in ascending order is another way of saying that. And also the distance between the middle and the first is the same as the distance between the last and the middle, which is equal to the value D. So given an increasing sequence of integers and the value D, count the number of beautiful triplets in the sequence. For example, the array 2, 2, 3, 4, 5, given the value D of 1, there are 3 beautiful triplets by index. You get 0, 2, 3, which is the first one, this one, 3, and the 4. So the 2, 3, 4 basically, as well as 1, 2, 3, which is the second 2, 3, 4. So you recognize that some numbers can be repeating, but need to be considered uniquely within the combo of the triplet. And we can test that the first triplet has a distance of 1 because 3 minus 2 and then 4 minus 3 is also 1. Here we're given example 1, 2, 4, 5, 7, 8, 10 with a D of 3. That means the 1, 4, 7 work, the 2, 5, 8 work, and then the 4, 7, 10 also work. Okay, the thing that it's getting to me is like the fact that it's sorted. Maybe there's something I can be eking out there. I think for the most part I would do because I think in the end you need a running count because of the number of unique values. Again, having multiple 2s and multiple 3s, and the number of combinations kind of gets multiplied. So I would want to know the count of all those. Then you just multiply them together. So what I would do is I'd have like a running dictionary or hash map, have the key be the number in the array and the value be the count of how many times that thing has occurred. Then what you would do is you'd go through all the keys and then check to see, okay, is there another key that is above me by D? So you add D to the key, plus and minus, and then see, oh, are those there? If they are, then that's your triplet, and then you just like multiply those counts together and then you add that to a running total. I think that's how I would tackle that. I believe that's big of N doing it that way. Okay, so let's write some code. Keep a running count dictionary, loop through list to get counts, loop through, so keep running total, loop through keys, and multiply for combo, and then you just return that total. Okay, I think it'll work. And let's start writing some code here. So my counts equals some dictionary, loop through each. Okay, so for value in array, if value not in counts, we also like counts val equals 0. At the end, we just add 1 to the count so that we have a running count there. So let me just do a quick return counts at this point and kind of see what's going on with a quick test run to see if it's working the way I think it does. All right, here for example, so all these are the keys being the number in the list and then the value being the count. They're all unique. We're going to then go through the keys and do a kind of a lookup to see, okay, if I add and subtract D, do I still get, are they there? If they are, then we have a triplet, and then we just multiply those counts together because that gives you the combo, and then we just add that to a running total. All right, so let's do that. Total equals 0 for key in, I mean, technically I can also get the count out here, so I can get use dot items, so I can get both the key and the value. All right, so I guess we could say this is also the val, so I can call it what I called it before. All right, so check above and below for a triplet. Above val, that equals, I'm going to use dot get basically. So counts dot get, we're going to take the value plus d, and then we just copy that, and we're going to do minus d, and this is below value. So if those two exist, so if above value and below value, that means they're not none, then we can say we have a triplet. To our total, we will add the current count times, oh, actually, this is not the above value. This is the above count, because this is the above value. So this is really the above count. So we have the above count times the current count times the below count. That will give you your combo. And so now we have, instead of the value, we have the actual count here. All right, and that's being added for each one, and then we return the total. Let's see if this code works. Error, dictionary object has no attribute item. Correct, because it's called items with an S. Sorry, Python. It's my first time coding in Python, so, you know, gotta give me some leeway on that. Okay, we got some passing stuff. Let's submit some code, and they pass. Booyah! All right, very good. So usually this is where the interviewer would say, hey, can you do better? So I'm going to see what I can do here. So let's first go over some time complexity, because the time complexity here is big O of n, because you're going through the list. All that else is constant. This is going through the keys. So this is going through each unique key value pairing. So that at worst case would be big O of n. So the total time complexity equals big O of n plus big O of n, which equals big O of 2n, which you can convert to just big O of n here. So the interviewer would probably ask, hey, can you do better than this? So you can imagine like looping through this and getting to the point where you're like at 1, 2, 4, 5. And then once you get to the 7, you can look back and basically look and say, okay, there was a 4 and there was a 1. And that's when you know there's a triplet, because it's sorted. The fact that it's sorted allows you to kind of cheat a little bit by assuming that you can look two values earlier and look up to see if they exist. That could work. And you know that because it's sorted, you're not going to encounter those values again. So what you would do is you take a running count, and anytime you get to the last value, basically, so you're hinging this all on the last value being the consideration. Okay, so I think I could actually bring this from I mean, it's a minor thing, right? But I can take this, I think, from 2n and bring it just straight up down to just n by doing some shenanigans, because it's sorted. So that sorting actually allows you to eke out a little bit more efficiency. So even though I have a working solution, I think I can make this a little bit more efficient. Okay, so what this means is I'm going to grab this sort of code here, but it's not going to be exactly the same. What I'm going to do is, because it's sorted, I have to check, like, I have to do minus d once and then twice, basically. So minus d and minus d again. Okay, so this is really the first val count, second val count, and the current value count is this, whatever this is. But we don't care about that really. But anyway, so here we're gonna kind of do this similar check here. Okay, and we keep a running total, so I need to keep my running total up here. We're not looping through the keys anymore, so that's out. So what we're doing is we're checking to see, hey, do you have a first value count? That means there's a first value, so that yes. And if there's a second value count, then you know you've encountered a triplet. And what you add here is just the first value count plus a second value count. And the reason why you only add those is because if I go up here, so let's say there's a 1, 4, 7. That means when you encounter the 1 and the 4, nothing happens, because there's nothing that's like 2D down the line, right? But once you hit the 7, you can see, oh, there's a 1 and 4. And what you need to do is consider the number of combos that they have themselves. So that means you don't add, you multiply them. So you do need to multiply those. But what you would do is multiply them, you know, by the number of times you see the third one though. But because we're only seeing the third one as we're going through the loop, that means we have to like do that every time we see multiple 7s basically. So the next time we see a 7, we're adding this again. So it's effectively like we're multiplying by the third value, but we're only doing it when we actually get to that third value. Okay, so here is the loop. I think this should work. So let's run some code. It works. Submit some code. Oh, look at that. That's awesome. Wow, I eked out more efficiency. Even though, so I went from, so let's go back here. So let's look at the time complexity now, which is just big O of n. So while you're looping through it, the first time I'm doing this check. So I'm checking for triplet, check for triplet. And you get the 2 previous values. And if they exist, then you can just start adding to your total right away. And so you don't need it to loop through it again. So there is no big O of n here. There's no 2n. It is just, folks, look at this. This is just the best efficiency. So that's nice to see. And that's a really good thing to kind of exercise while you're doing your coding challenges, is that yes, you get to a solution, but you could always go back and think, is there a way to make it more efficient? Because that is something that is going to be asked on the coding interview, and it's definitely worth considering, even if it's something as silly as going from big O of 2n to just regular n. Anyway, folks, if this is the kind of content you enjoy, please make sure to like, subscribe, do all the good things, and I will see you next time.